Okay, this is Math 7, Unit 5, Lesson 5, representing subtraction today. And so today we're going to be subtracting signed numbers, positives and negatives. All right, so let's begin first of all looking at 5-2, subtraction with number lines. It says here's an unfinished number line diagram that represents a sum of 8. Okay, has a sum of 8. We're going to get there at 8. How long should the other arrow be? Okay, so because it's a sum of 8, we know we're going to be combining two arrows together. So we have this first part, which is a 3 value, and we know we're going to be adding an additional arrow to make it a sum to get up to 8 right there. So the other arrow should be this distance from here to here, which happens to be 1, 2, 3, 4, 5. So we would say it's going to be 5 units long to go from tip to tail, right? Go from here to here. All right, that's what we do. For an equation that goes to this diagram, May writes 3, so May writes the arrow. Let's just take a look here so we know what we're doing for a second here. May does the arrow value plus the unknown equals 8. So in this case here, it's 3. Okay, 3 plus I don't know equals 8. Tyler, though, look what Tyler does. Tyler does the dot, right, where the point's at. He does the point, which is 8, minus the arrow, whatever that's going to be. In this case happens to be a positive 3, which equals what he doesn't know there. All right, do you agree with either of them? Well, I would say we agree with both of them, right? Because 3 plus some missing number is going to be 8, in which case it happens to be 5. Okay, and for Tyler, he's saying that if we do 8 and we should take away the 3, okay, 1, 2, 3, it gets us to the same point of 5 for in terms of a solution. They are both right in what they're saying. They are what we would call an equivalent equations. Okay, because they're going to be giving the same solution. Either 3 plus the unknown equals 8, or 8 minus 3 equals the unknown. These are equivalent equations. Now in terms of what the unknown number is, we would say what's missing is going to be 5, right? Because I can do 3 plus 5 to get 8, or I can do 8 minus 3 to get 5, and that becomes my solution there. Okay, so keep in mind here that May is going to be using the arrow and Tyler's going to be using the dots here for this next section. All right, because here are two more unfinished diagrams that represent sums. Okay, so we have these diagrams here. For each diagram, what equation would May write if she used the same reason before? So May, we said before, she used the arrow. Remember, her thing was the arrow plus the question mark equaled the number, equaled a number of some point here. So look at her thing here. Her thing was the arrow plus question mark equaled the point. I should have backed up there, equals the point. Where Tyler was point minus question mark. So let's do it this way. She does the arrow plus the question mark equals the point value. Okay, so let's see here for each diagram. For the first one, let's call this A and we'll call this B. So for A, what she would write is she would say the arrow, which is going to be at negative 3, right? Goes from 0 to negative 3. Sorry, a little bit out of the frame here. So the arrow is negative 3 plus, we don't know, an unknown value is equal to our point, which happens to be at 8. There. For B, she would say the arrow, which has a value of 3 plus, I don't know, an unknown quantity equals our point value at negative 8. And that's what she would say there. Now for Tyler, Tyler used the method of doing the dot, we said, the point plus, or minus the arrow, the point minus the arrow equaled an unknown. That was Tyler's kind of strategy. So looking up here then for Tyler, what would he do? Well, for A, what he would do, he'd take the point, which is at 8. I'm going to zoom up just a little bit there. He would say 8 minus the arrow, which is a minus 3. A minus 3 equals an unknown value. And for B, he would do the point, which is negative 8, minus a value, the arrow value, which is 3, equals an unknown value there. Okay, so those are the two equations. So the A equations, we have negative 3 plus something equals 8, or 8 minus and minus negative 3 equals the unknown. And for B, we have 3 plus the unknown equals negative 8, or negative 8 minus 3 equals unknown. So how long should the other arrow be, is kind of our question there. So that's a great question. So how long should it be? In both cases here, for A, for the value of A, the arrow for A should be at, let's take a look here. If I'm at negative 3, let's do this one for looking at this. I'm going from negative 3 and I'm going to move up this way all the way to 8, here to there. I'm going to be going up 1, 2, looking at 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be 11 units long. For B, if I'm thinking about being at positive 3 and then having to move all the way down here to this way, right? How many units is that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, that arrow is going to be 11 units long for B as well. So what number would complete each equation? Well, for A, the number that's going to complete that equation is going to be 11 with an arrow to the right, right? Because it's positive. Whereas for B, we would say it's actually be a negative 11, okay, with an arrow to the left. Now the units are still going to be 11 for both of them. That's how long the arrow is, but the value of it, positive or negative, depends upon which way it's pointing. So in our case here, this one's going backwards, or negative 11, and this one's going in a positive way, positive 11 there. Okay? So that's our difference between how May and Tyler wrote the equation. Draw a number line, next one here, for negative 8 minus a negative 3, what is the unknown number? So there's a couple ways, of course, to do this, right? We can draw the number line out, and we can start here at, let's just go 0, and we'll go 1, 2, 3, 4, 5, 6, 7, 8. So here's negative 8, negative 1, negative 2, negative 3, negative 4, 5, 6, and 7. Right? So depending on which one you want to look at, how do you want to do this? If we did the Tyler method, right? The Tyler method is the point minus the arrow equals what we don't know. So we could put a point down at minus 8, okay, and we're going to subtract a negative 3 to here, and so what is unknown is this space in between, right? It's this gap from here to here. That becomes the question mark there. If we did the way that May does it, we would do a minus 8. We would draw an arrow down to minus 8, down that way, for example, and we could then go back the other way and say minus a negative 3. That's like going to be going this way, minus a minus 3 this way, end up at a negative 5. So the unknown number is going to be a negative 5. That's where we end up at here. We can see we end up at negative 5 there. And the distance here is 1, 2, 3, 4, 5. So the distance here is going to be a 5 as well. Okay, that's a distance of a 5. And so we would say it's a negative 5 is the unknown number for that solution. Alright, and that's what we have so far. Okay, in the summary it kind of comes together, so hang in there for a little bit more. We can add instead. Alright, so this is what we want to talk about, because that other one, you're like, is there another way? Yep, there is. So match the diagrams to each expression. We have 3 plus 7, 3 minus 7, 3 plus a minus 7, and 3 minus a minus 7. So from what we know here, this is going tip to tail. This is like, so tip to tail is sum usually, right? So this becomes a 3 plus, and here we went 1, 2, 3, 4, 5, 6, 7, 3 plus 7. And because we're going tip to tail, this is just going to be a 3 plus 7 like that. And so that matches there, no problem. This is just simply 3 plus 7. This guy here, we have a point, and then we have this value there. So it's like we're going down to negative 7, and because we have a point there, we're going to subtract something, it looks like, to end up back at the 3. Or at least we have a negative 7 value at this point here. So we could say this is going to be 3 minus a minus 7 to figure out the difference between the distance between here and here. Okay, so that becomes 3 minus a minus 7 there. This one, it looks like we're going to be adding a 3, right? Plus 3. And then we're going to add to that, go back this way here, minus 7. And this guy here, we'll start with a point again. The point's going to be 3. Okay. And what are we doing here? We're subtracting, it looks like in this case here, we have a line of 7, so we make that just a positive 7 there. Okay. So our point becomes what we start with there, a little bit like what Tyler was doing, right? So our subtraction problems, notice here we started with a point, 3 and 3, and we subtracted whatever that arrow was, a minus 7 and a positive 7. Okay, which expressions in the first question have the same value, and what do you notice? Okay, so in this one here, we have 3 plus 7, which seems to equal 10, right? 3 minus a minus 7. The distance from here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 minus a minus 7 is 10. In this case, 3 minus 7 this way puts me at location negative 4. Negative 4. And then 3 minus 7 is also going to be equal to a negative 4 there. Okay? So a little different there, that difference there. So what we notice is that A and B have the same value, and C and D. And the big thing we should notice here is that something like 3 plus 7 is the same as 3 minus a minus 7 or negative 7. When I subtract the negative number, it's the same as adding. Notice this one here. If I do 3, this one here, 3 plus a negative 7, that's the same as just simply subtracting a number. So if I'm adding a negative number, it's the same as just subtracting the number. Okay? But a big thing here is subtracting a negative is the same as adding a number there. So subtracting is basically the same as adding the opposite. Subtracting is adding the opposite. So here's subtracting a negative, which means add the opposite. Here is subtracting a positive, right? It's a positive 7, which means add the opposite. And that's what we're supposed to notice there. We're adding the opposite. So let's take a look at some tables and see what we notice. So an 8 plus the opposite has a value of 0. Okay. This one is subtraction is the same as adding the opposite, so I could write it at 8 plus a negative 8, which is still a 0. 8 plus a minus 5, adding a negative 5, is going to be 8 minus 5, which is a 3. And 8 minus 5 is still a 3. 8 minus a minus 12, or 8 plus a negative 12 is negative 4. And 8 minus 12 is also negative 4. So notice how these, while they might look a little different, end up doing the same thing. Adding a negative is the same as subtracting. Adding a negative is the same as just regular subtraction. Over here, we have negative 5 plus 5 is 0. And again, a negative and a negative is the same as just adding, a subtraction is the same as adding the opposite, so adding 5. So it matches there. Negative 5 plus 9, well, again, subtracting is the same as adding the opposite. So negative 5 plus 9 is the same as negative 5 minus a minus 9, so we have a positive 4. And then again, it's the same as adding the opposite. The opposite of negative 2 is positive 2, so negative 5 plus 2 is negative 3. Okay, and that's what we do for those ones right there. So in summary, the big summary from this, and you can read through the notes here about the arrows and how this works here, but I think your big takeaway is really down here where we recognize that in general, okay, A minus B is equal to A plus a minus B. Okay, so when I have a number 3 minus 4, this subtraction is the same as 3 plus a minus 4. So subtraction means adding the opposite. That's also important when we start looking at subtracting a regular negative number. So it's 3 minus a minus 4. So subtracting a negative is the same as adding the opposite. And the opposite of a minus 4 is a positive 4. Okay? And that's just important to keep in mind as we move on to today's homework. So let's take a look at that together. Write each subtraction equation as an addition equation, okay? So it means add the opposite, so a plus, instead of minus 9, the opposite of 9 is going to be a negative 9 equals 6. All right? Over here, we do p, and instead of subtracting a positive 20, we're going to add a negative 20. Okay? Equals negative 30. Here, we're subtracting those, so it's to add the opposite. So we're going to write z plus, the opposite of negative 12 is positive 12, equals 15. And then over here, we can make that opposite, x plus 7 equals negative 10. So that's writing each subtraction as an addition equation, okay? If you want to get the value of the variable by itself, which you could do, we could do that there, we need to move this to the other side. So that's going to be then adding, in this case here, would be adding a 9 to the side. So you'd have a equals 6 plus 9, right? Instead of negative 9, we're going to move to the other side to make it plus 9. This becomes a p equals, we have already a negative 30, and the opposite of minus 20 is plus 20. For z, we have it equal to 15, and instead of plus 20, we do minus 12. So plus 12 minus 12. And again, we want to make addition problems, so we'll do add and minus 12. And then for x, we would say it's going to be equal to negative 10 plus the opposite, which is negative 7. So that's another way your teacher might have you write those equations there. I think if you just did the simple part here, this is probably fine. This is rewriting it in a different way altogether, really, okay? So this is a whole different way of doing it, all right? So, two different ways. Same equation, just this has the variable on by itself. All right, find each difference. If you get stuck, consider drawing a number line, okay? So 9 minus 4. 9 minus 4 is going to be 5. 4 minus 9. Again, we do the signs are different. We could rewrite this as we wanted to. Let's do what we were working on. This can be rewritten as 4 plus a minus 9. Now we know the signs are different, so we find the difference. 9 minus 4. We're going to keep the larger sign with a larger magnitude, so negative there. 9 minus 4 is 5, and we keep the minus sign, so we have minus 5. Here, we're going to add the opposite, so that becomes 9 plus 4, which will equal 13. Here, we're going to add the opposite, so we have negative 9 plus 4. Because the signs are different, we find the difference, and we keep the sign with a larger magnitude, which is negative. 9 minus 4 is 5, and we put a minus sign in front because we just keep the minus sign carrying along. Here, this becomes add the opposite. Signs are the same, so we find the sum and keep the sign the same. 9 plus 4 is 13, and we keep the sign the same. Here, we add the opposites. This becomes 4 simply plus 9. And 4 plus 9 is 13. Here, this becomes 4, negative 4 plus 9. Well, negative 4 plus 9, we're going to find the difference because the signs are different and keep the bigger sign. It's positive. So 9 minus 4 is 5, and we keep it positive. And here this becomes add the opposite. The signs are the same, so we find the sum and keep the sign the same for negative 13. A restaurant bill is $59. You pay $72. What percentage gratuity did you pay? All right, so think of it like this. You're going to be paying a different amount of money. Let's see how much you paid. $72 minus 59. That's your total. That was your subtotal, so we're going to borrow there. We find that you paid an extra $13 in gratuity. So $13 is what percent of the $59 bill is really the question you're being asked there. So 13 is what percent, we'll call that x, of 59. Okay, so we solve for x. We'll divide both sides by 59. 13 divided by 59. And 13 divided by 59 is 22, or 0.22, right? So 0.22 equals x. To make that a percent, we move it over that way to have it become 22% was the amount of tip you paid on that bill. It's a pretty good tip. I guess you liked the waiter a lot. Way to go. Must have given you a lot of refills on your drinks. All right, find the solution to each equation mentally. So 30 plus some number equals 40. So we're going to add a little bit more, perhaps a 10. 500, take away something gets you to 200. You can think about a 5 minus what gets you to 2. It's going to be a 3. So we're going to be subtracting those. So we're going to take away 300. A negative 1 and something else gets you to a negative 2. So we're increasing in some sense by a negative increasement. So negative 1 would be there. And then here we're going to get to 0. So whatever that is, we'll do the opposite. Negative 3, 5, 6, 7 for that solution there. The next one, we have a table coming up. 1 kilogram is 2.2 pounds. Complete the tables. What is the interpretation of the constant of proportionality in each case? All right, so let's take a look here. In this case, the first one, we have x and we have y, and we can see what's happening in two tables is this. We're changing the columns around a little bit, aren't we? And that's okay. You can change them around. You just end up with a different k value as you do that. So in this case, our constant proportionality is 1 over 2.2. That's our y over our x value. That's our k value right there. Okay, y over 1.2, which means I can take 11 and I multiply it by 1 over 2.2. So 11 over 2.2 is 5. 5.5 times 1 over 2.2 is equal to 2.5. And then 1 times 1 over 2.2 is simply 1 over 2.2, which is the same as 0.45. Okay, so kilograms per pound, you end up with 0.45 kilograms per 1 pound. Over here, our constant proportionality k value is our y over our x, or just simply 2.2. So how many pounds per 1 kilogram? It's 2.2 pounds per 1 kilogram. We can then solve this out by multiplying by 2.2. We have 15.4. Multiply by 2.2, we have 66. And multiply by 2.2, we end up with 1.1. All right, and that's the idea today for how we're doing that with portions, and that's a review. So we'll see you next time.